Hello. Welcome to the North Dallas Developer Group. Thank you, Russell. Today, I'm going to be talking about Git internals through the lens of VSCode. My name is Corey Drew, and I am a Git enthusiast. Monday, I actually hit 11 years here at Improving, and we have 17 offices now. I love it here. I love the people. I love the culture. And here is a tiny sliver of some of our upcoming training. So in addition to the Agile training that Russell mentioned, we also have a new AI training track. It's really incredible. If you'd like, I will show this again at the end. But I have a lot to cover tonight. So let's get started. I'm here today because someone at a conference, a good friend of mine, told me this, and it caught me by surprise. He said, I want to understand Git better, but every talk I attend is taught using, so they lose me. And that really surprised me because of who this was. Like, he's one of the smartest people I've ever met. He's amazing. He does like data science and so I thought that people were more comfortable with command line now, especially because you pretty much have to use command line to use JavaScript, et cetera, than when I started Git, which was so long ago. I had no choice but to learn command line. I decided to try it for just 2 weeks on February 1st, 2012. And I know that date because I blogged about it, and that was the date of this post. And this is what I had to say. Please say I'm starting to feel less repulsed by command line than I ever have before. So my point is, although I swear by the command line now instead of at it, I've been there and I can relate. I feel your command line averse pain. Actually, I do want to, who already uses Git and who uses it with command line? Okay, and who uses it and just kind of feels like it's a necessary evil? I don't really understand it. I don't know what this detached head stuff means. And all right. So I want to teach you Git internals because I really believe that just demystifying Git makes all the difference, even if that means not demoing with my newly beloved PowerShell. Well, newly beloved the past decade, but I use Posh Git. It's PowerShell Git. So here's a quick roadmap of what I'm going to be covering tonight. It is pretty ambitious. We are going to start with Git init, and then we'll talk about the head file, detached head. What is an attached head? A head is an actual file. And so is the index file. If you've ever heard someone like the Gitty people saying, hey, stage it or add it to your index, and they kind of use these interchangeably. Tonight, we're going to learn why that's used interchangeably. We're going to talk about there are 4 types of objects that Git is made of. The first type is the blob. The second type is the commit. The third type is the tree. And then the fourth type is a tag. We're going to talk about patch and diff and what that means. What they are, how they're created. We're going to talk about merge commits and a merge commit workflow. We'll then talk about rebase and a rebase workflow. We're going to talk about cherry pick and squash. And I have some really amazing references for learning more. And then we'll end with a Q&A. So since I've geared this talk for the command line averse, I'll be showing you all of these through the lens of VS Code. Showing you combo, though, of the GUI and where and how to see commands that get run, and more importantly, what they do under the covers. So let's get into VS Code. So I have created a new empty directory and opened it in VS Code. When I go to the source control tab, VS Code knows there's no Git repo in the folder I've opened by the lack of a .git directory and gives you this option. You can also see the Git output window, how chatty VS Code has to be to keep the Git GUI up to date. So when you when you click initialize repository, you can see in the Git output window that VS Code calls get-init-b main to initialize your new repository. The -b main ensures that the default branch is named main because traditionally it used to be master. And so that just makes sure that, hey, VS Code just says, hey, I want to make sure that your default branch is named main. So I don't recommend this, but for this demo, I temporarily modified my VS Code settings like this so we can see the contents of the .git repository folder since it's hidden by default. You can see that what we have now that we've called get-init is we have an empty directory with an initialized Git repo ready to track files. I'll open up this hidden folder to point out a few things. There's a file named head, and you can go into any repository that you have, and you can open this head file. It keeps track of what you're working on. The syntax here is for an attached head. In this normal state, head is a symbolic reference. It points to the name of a branch like refs heads main. Any new commits made will update that branch, and head will indirectly be updated with these new commits through that symbolic reference to that branch. You can see here, there's currently no file in refs heads called main, but that is because we have no commits yet. Get-init just created a placeholder. So for a better example of an attached head, here's the actual Git source code. And the actual Git source code is so cool because you can actually see the first Git commit ever, like from 2005. It is so cool. Here, head is a symbolic reference to refs head's initial commit. And this is what the initial commit branch file looks like. Let me expand that. If that looks familiar to you, it's because all it takes to create a branch is a 40-character file. A branch is nothing more than a label to the SHA-1 hash of a commit. But let's go back to this for a minute. There is another option for the head, and that option is called detached. When head is detached, it points directly to a specific commit, not to a branch name. This means any new commits made in detached head state are not associated with any branch. So it's going to be hard to find. Git can still do that because of the way that Git works. We'll talk about parents in a minute. It stores its parent, and that's how it keeps track of its history. But that is the only difference between a detached head and attached head state. So to be clear, there is a file named head in the root of your Git repo whose sole purpose is to keep track of what you're working on, what branch or commit you have checked out. Git's happy state is when head is a symbolic reference because when you commit to a branch, it indirectly updates the head as well. Is everyone with me so far? Does anyone have any questions? Okay, you good? Back to our new repo. I've created a file in the working directory. I want to point out that the objects folder is empty. Keep an eye on it. When we add this new file to our staging area, we tell Git we want it to be part of the next commit. If you hover over the button, it says stage changes. And this talk is for us that have used command line for a while and want to see where these things are located in VS Code, as well as VS Code users. So if you hover over the button, it says stage changes. Oh, you can see there's a green U next to it, meaning the new file is untracked. Clicking that plus button is the same as doing this in the command line. Git add hello world.txt. Now you see there's an A for added to the index. When you hover, it says index added. What is the index, you say? Well, let's go find out. Remember what our Git folder looked like before. The objects folder had no objects. And look here between head and hello world.txt. Head was the last file in the Git directory before we staged hello world.txt. After staging that file, we now have two files in the Git repo. Let's see what they are. Index is a compressed binary file that represents the content of your working directory, the entire working directory. The index is what Git uses to create the next commit. So let's take a look at it right now. This command is how you make the compressed binary stream readable. I just piped it to my clipboard and pasted it into Notepad to show you the contents. So what are we looking at here? This line represents the file we just staged. The first part represents the file mode, executable, etc. 100644 represents a regular non-executable file. You can see the file name at the end here. But what's this in the middle? And why does it look like this? A Git repo is made up of 4 types of objects. 3 of them are used to create a snapshot of your code base. In Git, when you stage a file, it takes the content only, creates a binary stream, which it then compresses. That compressed data becomes content of the saved blob object, and also that compressed data, the file content itself, gets run through a hashing algorithm to create a unique name of the object based on the contents of the file. That means Git names its objects based on their content, which means we get checksums built in for free. Git repository object content cannot get tampered with unknowingly. Yes, yes, it's so cool. And if you want to get really technical, Git also adds a header. You can read about it here. Go nerd out on it. It's really fascinating, but it goes a lot. It even goes deeper. The important part is nothing is part of a blob object in Git except the content itself. Once Git stores those contents, it can reference it all at once, but no more space will be wasted storing it again. So, knowing this, let's go make a bunch of copies of our original file. Heck, let's throw a folder in there and see what happens. In VSCode, I can stage them all at once with this button, which is the same as git add dot. Now that we've staged them or added them all to our index, let's go look at what that did. Nothing new has been added to our object store, even though we have 6 more files in our working directory. Let's run this again and take a look. That's quite a change. The index is keeping track of every blob and its respective path for the next commit. If I commit right now, the entire working directory's info is laid out for you right here. This is what your commit snapshot's contents will be. Note, even though the files have different names and paths, the contents are the same. So it's stored exactly once and compressed at that. This is why Git is so efficient with its space usage. In fact, I calculated the entire Git repository since 2005 takes less than 300 megs when you pull down all of that history. It's just incredible. Yeah. That's a great question. And so the full, that's for performance. So if you look at how it's actually stored, the first 2 letters get put in a folder, and that's for seeking. And so the entire SHA is F3, F5D, as you can see right here, but it's for optimization. Yeah, yeah, yeah. Yes, yes. Yes, in fact, if you look at that file, it's gibberish, just like the index file. But you'll see in a minute, there are commands that you can run to see what the text is. Yep. Any more questions? No, this is just the CLI. This is just the Git CLI. Oh, the status. Oh, the status. Yeah, I use PoshGit. Yeah, yeah. There are a few. That's true. That's true. Yes, you can add the status in Bash. You can add it in the new Windows, whatever the new Windows command line is. Like I think it, yeah, the terminal. They have a lot of improvements lately. I love the tab completion with PoshGit. I love everything about PoshGit. Oh, I even use it on my Mac. So it's completely cross-platform. It's incredible. Okay, so let's create our first commit. In VS Code, this is where that lives in the GUI. If you don't fill out the message box, you can still hit the commit button, but you will be prompted for a commit message. And sadly, the Git output is so verbose, it's basically useless. Like when I decided to do this talk, I was like, oh, there's a Git output window in VS Code. I'm going to show that. You can figure out what the command line is. No. No. But clicking that button is the equivalent of running this command, git commit -m initial commit. Creating that commit just created 3 new objects in our repo. Now remember, a snapshot is made up of only 3 types of objects. We've already seen a blob object. If we use a command that you will never need to know, we can see what type an object is. So running it on that first object in our repo for sanity check shows that this type is indeed a blob object. This first new commit is a tree object. The second new object is also a tree object. Does anyone want to guess what the third and final new object is? Type. There's our commit object. So now let's go take a look at our commit object's contents. By changing this T for type to a P for pretty print and piping the contents to my clipboard, we can see the decompressed contents of our first commit object. There's not much there, is it? Does that surprise anyone? That's all that makes up a commit. The first commit is the only one that won't have a parent commit to reference. Our first commit only has a commit message, a committer name and timestamp, an author name and timestamp, and a root tree. Well, that is just content. And how does Git store its content objects? Look familiar? So this minimal text might surprise you if you're used to seeing the GUI representations of a commit, like my favorite Git GUI, Git K. Has anyone heard of Git K? I know you have. No one? Wait, please raise your hand if you've heard of, do you use Git K? It's the best. I almost did a Git K talk, just all Git K. I love it so much. Okay, so Git K was the first GUI, Git GUI, created the same year that Git was in 2005. What's beautiful is it hasn't really changed. It's not pretty, but it's functional and it does everything I needed to do, and it looks the same cross-platform, which I don't understand because it looks like an old Windows app, but I love consistency. So Atlassian has a great section that's really helpful, and there's a QR code for it if you want to read up on it. So Git K is always at your fingertips. It's automatically installed. It's very lightweight, and if you ever just want to see the visualization without having to install an extension or whatever, you can just type Git K. You can type Git K with a lot of arguments to see certain things, and it's very, very powerful. So, but even my favorite Git GUI makes a commit look like it's much more complicated than it actually is, doesn't it? We see the author and committer, name and timestamp. We see the commit message, and that's all that really looks like here, huh? The SHA-1 ID, well, that's the name of the file, so that's part of the object. The GUI doesn't show you the value of the single tree object that we see when we just look at the raw commit object. But this list isn't part of the commit object itself. Let's take a look at this tree object now. In Git, to see a tree, you have a couple of options. Get cat file -p works, and get ls tree also works. Both will give you this. So what is a tree then? It's just a list of blobs and trees named for its content. No dates, no timestamps, just content. Remember how we said 100644 was a regular non-executable file? The 04000 mode indicates the object is a directory. And as you can see here, it references our fourth object, the other tree that was written. That looks like this, by the way. So to recap, all a tree object is a list of tree objects and blob objects with metadata like name and mode. And when you see it like that, it makes the concept of how do I merge branches make a little bit more sense. So I found this image and it made me laugh. I'm pretty sure their question was about binary trees, but I'm just stealing it for a giggle and modifying it. So no matter what the commit consists of, different authors, different commit times, different commit messages, if the commit's root tree is pointing to the same tree object as a different commit, are they the same tree? Does it have the same content all the way down, the entire commit, every single file in that commit? Yes, the answer is yes. Those two commits will have the exact same content all the way down. Every folder and every file is the exact same, guaranteed. And because one of you might be bothered by what's the fourth object, even though I gave it away in the agenda, here's a hint. Just like a branch is a movable pointer to a commit object, a tag is an immovable pointer to a commit object. To create one using VS Code, there's a two-step process. After you click the Create Tag button, VS Code asks you for the tag name. This is the equivalent of a branch name, like main, so it can't have any spaces. Tags do not require a message, so here's the command line equivalent for what's called a lightweight tag. If you want to add a message, VS Code gives you that option in step 2 after hitting the Enter key. Like this. The command line equivalent of creating an annotated tag is the familiar -m for message. We just created an annotated tag, so let's go look at our objects. Yes, the fourth type of object is a tag object. And once again, if we change this T to a P and pipe it to our clipboard, we can paste the decompressed contents into Notepad to see the contents. A tag is an immovable pointer to a commit. And you can see that commit, our first and only commit so far in our repo, referenced here. And here's what a tag looks like in the GitK GUI, almost identical. And the last thing to note is, just like you get a new file in refs heads when you create a branch, we got a new file in refs tags that points to our new tag object. Side note, a tag without a message saves a file to refs heads tags too, but points directly to the commit, kind of like a detached head. Yeah, or kind of like a branch name, instead of making a new tag object, there's no metadata in a lightweight tag, like tagger name and date, for example. Anybody have any questions? Symbolic reference. Yeah, they're nicknames. They're nicknames for our convenience. Yeah. Yeah. Where's the what? Where's the date? I don't know about tags, but I know like names on the files. you can see when it was committed. That's the only date that you'll see. Yeah, like here, that's the date right there. I know it doesn't look like a date. That's the date. So that's the date on the tag, and the commit will have a similar, the commit has an author and a committer date because those can be different. The author and the committer, like for example, when we go into the cherry pick thing, the author date is going to be when it was actually created, but the cherry pick date was going to be the commit date. And those can, like I can cherry pick something that you had in the repository, and you'll be the author and I'll be the committer for that cherry pick. And they can have different authors, different names, but they're stored separately and they include the date. But the dates all live on the commits or the annotated tags. And that's it. Everything else is it's all content based in Git. The blobs, the trees, they're just content. Blobs are nameless, faceless content. Is that where I was? Okay. So let's add a second commit. For the second commit, we're going to create a file. We want to iteratively change, iteratively, hard word, to be a parody. It's a work in progress. So we'll start with the actual original lyrics. We've created the file in the working directory. Note here, the VSCode editor allows you to write multi-line commit messages. Here's the command line equivalent. You can see, you can add as many lines as you want, just -m, quote, -m, -m, -m. I do want to point out here that we haven't staged the file. In VS Code, if you click the commit button with nothing staged, it will give you this prompt. There are no staged changes to commit. Would you like to stage all of your changes and commit them directly? And here is the command line equivalent, which the control freak in me does not like at all, but it exists. All right, so now that we've created our second commit, let's revisit. Dash A is all including deletes, capital A. It used to be, I don't know if it still is. I know originally when I first started doing Git, dash lowercase a was the same as dot. Dash uppercase A was include deletes. And now it seems like I can just add dot for everything. But they have changed that functionality over the years. Okay. Where was I? Okay. So now that we've created our second commit, let's revisit. Did we just update the head? Yes. Indirectly, because it's a symbolic reference link to rest heads main, which looks like this now. What? Yep, it's commit object. So let's look at this object now. All right, let's declutter so we can just read the content, and let's enlarge it. What's the difference from the initial commit? We still have a commit message, and you can see it spans multiple lines in this one. We still have a committer name and timestamp, an author name and timestamp, the root tree object, but also this one has a parent. Every commit will have at least one parent, except your initial commit. It's the parent that enables Git to calculate a diff. Git uses this to compare the content in a commit with the content in its parent to show you what changed. This parent object points to our initial commit. Now let's look at this new commit's root tree object. This root tree is a new object because its contents changed, but everything else you see here was already stored. So even though the commit represents the entire working directory, We only had to create 3 new objects for this commit. 1 commit, 1 new tree object, and 1 new blob. Everything else was already stored. So if you've ever been frustrated by the simplistic circle dot representation of commits and their lines and diagrams like this, it really helps me to think about every single dot as a can stand alone, read-only representation of the entire working directory at the time of the commit. Because each commit knows its parent or parents, diffs can be and are calculated on the fly. So keep this in mind when we get to what this diagram shows, which is a rebase. But for now, since you have to add an extension to VS Code to see your history, let's go back to Git K to look at our Git graph with a different lens. So there's an option here I'd like to point out. By default, most visualizers will show you the differences made in your commit. If you look closely, you'll see that there's a radio button that says patch. That is selected by default. The other radio button is the tree view option, which actually is more of a pure view of the commit. With the tree view selected, you can click to view each file and see its content in its entirety. No deltas, no changes, just the actual content that reference blob is pointing to. Which is interesting and can be helpful, but when I'm viewing Git history, I'm usually more interested in what changed from commit to commit than the entirety of all files that make up a commit. So this patch view is logically the default in every Git GUI I've ever seen. So, but what the heck is a patch? And why do I care? I'm just going to go deep enough to use this info to explain cherry pick. But I highly recommend this URL for a deep dive. It's really, really good. Let's go back to our original project and work on our parody. So first, we'll create a new branch called parody rewrite. In VS Code, you can create it like this, which will create the new branch pointing to the commit your head is directly or indirectly pointing at. Next, it asks you for a branch name. Creating your branch this way is the same as doing this in command line. You can see the new branch in rest head's parody rewrite. So let's make some changes. The first change I want to make is replacing all about that base with all about rebase. Let's look at the Git tab. In VS Code, if you click on a modified file, it will show you the equivalent of calling git diff, which I'm going to show you now to quickly point out some really interesting things. And I'm actually going bare metal nerd on this one because I can't paste this into Notepad and keep the color coding. So bear with me. I promise I wouldn't waste your time if this wasn't really cool. And also just let it wash over you. You don't have to memorize it or ever actually use it again. This is just so you can just start thinking about how Git works under the cover. So by default in a Git repo, if you just type git diff on the command line, you will get, Git will compare your working directory content to your index, which we've learned is our staging area. At first, it looks like a wall of gibberish. It's that gibberish that enables GUIs to display things like this and this zoomed out. So we can see what was changed in a file. Let's quickly dissect this so-called gibberish. So by default, Git's diff algorithm is a command that takes 2 text inputs and computes the difference between them. Well, what did we learn about everything in Git? It's all text, right? So now the first thing you can see is a line is all or nothing. Even if one character on a line changes, that entire line is added and deleted. Well, that's intuitive and very clear from here or any Git GUI. Let's look at what's not so obvious. What is this thing I've ignored every time I've ever run git diff? It might as well be a banner ad. It turns out it's pretty informative. As I learned recently from this same awesome link. Let's zoom in on that for a minute. Git diff always names a file A and a file B. In this case, the file name and path are the same, but the blob content is different. Since Git compares staging saved to our index file to the working directory by default, the stage content is A, the working directory content is B here. This, I swear, takes less than 5 minutes. So stay with me. We know the original blob object is stored in our objects, but Git calculates the hash of the new content dynamically. This object does not get stored in our repo until we tell Git to add it to our index. Now let's talk about these little fellas. These are called unified diff markers. Let's look at this one first and then go back to the first one. I'll explain why in a minute. I scrolled up so we can see the whole thing. This is called a hunk header. Let's zoom it. The negative 2511 part means in the original version of the file, the changes start at line 25 and span 11 lines. But hold on, we only changed 5 of those lines. True, but Git's diff tries to store 3 lines of context by default if possible, as well as an additional line of context in the header. So it can find it if the line numbers don't match when it gets applied. And here is the changed content. The plus 2511 part means in the new version of the file, the changes also start at line 25 and span 11 lines. Once again, we only changed 5 of those lines, but Git is able to include its desired 3 lines of context in the new patch. So now let's go back to that very first patch we skipped and take a look. Obviously, since the first 2 lines changed here, it can't save 3 prior lines of context lines in the diff plus a 4th in the header. So it starts with line 1, includes lines 3 and 4 because by default, it likes 3 unchanged lines for context. It includes lines 5 through 9 that were changed and ends on line 12 after 3 context lines. And here's that hunk's corresponding file B. So if you've ever noticed, whenever you do a git merge or you apply any changes and you get a merge conflict, it's typically within 3 lines. If 2 files change within about 3 lines of each other, Git will go, hey, I think I gave it my best shot. I think I merged it right, but I need you to verify. And sometimes you're like, yep, did it right. Other times you're like, nope, missing a bracket or whatever, right? But it's about 3 lines that Git is really excellent at, at merging, and that is why. So does anyone have any questions about that? I told you, less than 5 minutes. And that's the deepest we're going to get. We're going to come back up for Aaron. Okay, let's talk about merge commits. What is a merge commit and what makes it different than a normal commit? So for this, we're going to install an extension so we can see the Git graph in VSCode. And it's just called Git graph. I've opened a new repo, and I'm showing you 3 branches that have been created off main. Feature Y was created off main before the last 2 commits were added, but since these were created, a new branch named add git ignore was created, merged into main, and deleted. So now it looks like this. If I just look at main, it looks like this. Does everyone understand the graph? Does anyone have any questions about the visualization of the graph? That it's linear, starting with the initial commit, and every single commit is just the next. And then we branched, we added the git ignore, and we merged back in. Everyone good there? Okay. Well, oh, that's just the way that this visualize like, it's just this GUI happens to visualize it. This is one of the reasons that I love GitK and PoshGit is because it's consistent everywhere. This just makes it pretty. So you can see the tip of main was branched from, a commit was added, and that branch was merged back to main and deleted. Now, as beautiful as this extension is, there's misleading representations I want to quickly point out. In Git graph, when you click on a commit, you have no option but to view the diff between it and its parent. Because you can't see the entire tree for the commit, it would be really easy to think that Git only stores the differences. as opposed to calculating them on the fly from the parent. Additionally, it gives you the options of things to do, which is nice, but viewing files without leaving the graph is not one of those options. So as a reminder, here's what the patch view looks like in GitK. And here's what the tree view looks like. And you can click on any of those files and see them in the left pane. And you can scroll down and see them without having to leave. Now let's look at our first merge commit. Merge commits are special because they have more than one parent. Here's parent 1, and here's parent 2. The fact that they change, that the change shows up in the file list here is something I wish was configurable. Technically, unless you make an actual change to a file because you had to resolve a merge conflict, Git considers a merge commit to have no changes. Case in point, this is how it actually looks in GitK. The last thing that's interesting I want to point out has to do with these two commits. If I check out either of those commits, will my working directory change? Any guesses? Correct, it will not change. They point to the exact same root tree. Does anybody have any questions about that? Okay, yes. Yes, unless there's a merge conflict that gets resolved. If there's a merge conflict that has to be resolved, that is the only change that actually happens in a merge commit. Otherwise, it's just showing you metadata. Like merge commits are great for pull requests because it says, hey, this PR got merged into this and nothing, like that's all the changes happened along the way. And this is just a merge commit that shows how the working directory became what it is in this commit. The last thing Okay, so let's talk about a merge commit workflow. So now that the main branch is ahead of our feature branches, what are our options? Well, one option is to merge back to your personal feature branch, whatever you branch from. It's updated like this. By the way, just like GitK, GitGraph has nice contextual options. You can see I have feature Z checked out by the bold text and hollow circle. I right-clicked on main above, and I got this drop-down option. When I pick merge into current branch, I get this. They really do a good job making it very clear what you're confirming. Here it says, are you sure you want to merge branch main into feature Z, the current branch? I confirm and get this, which you can see has two parents when I click on the new merge commit like this. After I do that to all of my feature branches, my graph looks like this. So now we keep working, and after adding one more commit, feature W gets approved. Right now, feature W's graph looks like this. And after we merge it to main and delete it, main looks like this. But now the other branches are behind. So we merge in latest main to get our personal feature branches up to date. And you could say, well, of course it's hard to see the graphs when you're showing all of the branches. And to that I say, okay, but I just want to see my work on my feature Z branch. Well, how can I tell what applies to just my feature with all of that noise? It takes a lot of mental parsing energy to look at this and find the real work that only applies to this feature. It was easy-ish here because of the commit messages, but it's often not that easy. Well, what is another option? Let's talk about Rebase. So just like the Git graph extension lets you right-click and choose merge into current branch, it will also let you rebase current branch onto what you right-click on here. That will give you this pop-up. Are you sure you want to rebase feature Z, the current branch, on branch main? Clicking that Yes Rebase button without launch interactive rebase in new terminal, check, gave me this. Isn't that so much easier to mentally parse than the Guitar Hero merges? I want to be clear that for this example, feature Z represents your personal feature branch, which no one has based their work off of. Because even though in the end, that rebase branch points to the same root tree object as the Guitar Hero branch, the commit IDs of the commits change because the parents and timestamps change. So now that feature Z is approved, let's merge it into main and take a look. And here's main after that. Oh, all my feature Z work is together. Now we've rebased the rest of the features, and it really brings to light what a shoddy job I've done on feature V. But look, my work is all together. Now that I can see just my feature work without all of those merge commits in the way, I'd like to clean this up. For example, this file is named v3.txt, but my commit message says I added v2. Before we create our pull request that puts our commits into shared history forever, let's clean that up with an interactive rebase. To do this, you select one commit before the commit you want to change. That is your base. After selecting rebase current branch on this commit, you check launch interactive rebase in new terminal. And you will see something that is terrifying. Unless you have someone there to hold your hand. At least that was my experience. But I will tell you how to get out of this. Select everything in that file, delete, save, and close. That's how you cancel an interactive rebase. It doesn't seem intuitive, but just deleting everything in that file, saving and closing is how you just cancel out of there. I'm sure you've gathered this already, but I have VSCode set as my global git config, my default editor. So after you get out of that scary rebase text screen, let's install another extension into VSCode. Has anyone used GitLens? Yeah. The way GitLens extension handles git rebase actually knocked my socks off. And that's really big. Like, I had to have been really impressed because I'm such a command line freak now. Is this extension free? Well, the part I'm about to show you is. So with that extension installed, let's do this again. Oh my gosh, that is so much more discoverable and intuitive and better. So let's look at the options Git Rebase gives us. These options are 100% available in the text version, of course, but it's so much more intuitive and easier to learn here, especially if you don't have the resident Git expert that you're sitting next to. With all of us working from home these days, you know, it's gotten even harder. So, yeah, the Git Kraken team really outdid themselves with that. What an interactive rebase does is it gives you the opportunity to clean up after yourself before your code becomes part of the shared history forever. So for the first commit, I only have 4 options because you can't squash a commit onto what you've told Git you want your base to be. We want to reword this one, which is just, I want to give it a new message. That's what reword means. And I know we want to reword this one as well, but I can't remember what, and I'll show you a cool helper in a minute. So note, we have 2 additional options, fix up and squash here. We'll talk about those in a minute. Another really cool thing interactive rebase lets you do is either drop a commit altogether or rearrange them. I'll show you rearrange. Note my V7 commit is currently before my V6 commit. Now look, so that's drag and drop. So those little dots allow you to just rearrange them. The caveat, obviously, is that they have to be movable. You can't move a commit where you modify a file before the commit where you've created that file, for example. That'll fail, and it'll ask you to resolve that conflict. But it will fail linearly. The way Git Rebase works is it goes to the commit you're rebasing onto. Then one by one, it calculates the requested patch from its original parent, applies it if possible, and moves to the next one. If there's a conflict in any step, the entire rebase pauses so Git can ask you to verify what should happen. Once you resolve the merge conflict, it continues to the next one automatically, one by one, until the rebase is complete. So now when I hit start rebase, it will ask me what I want to reword this to in my text editor. Git gives you very helpful text. Everything with a pound sign goes away after you save, and I want to point out how helpful this is. It helps me be sure I'm updating the commit message properly. Once I'm happy with my change, I save and close the file, and Git continues on to the next one. Once again, this comes in handy, so I can change the message to this. Again, I save and close the file, and Git continues on to the next two, which just reorder the top two commits. It will complete automatically as long as there are no merge conflicts. Voila, much better. And of course, we could do it again if we wanted to reorder V1 and V3 like this. And there we go. Does anyone have any questions? Well, it's only... I don't know, but that's another reason I prefer the command line, because everything is consistent across whatever. Like, I don't know if GitLens has a writer extension, for example. I don't know if GitLens has, but I have a console in every single one of my IDEs. So I'm clearly a command line aficionado, but I also am very impressed with GitKraken's implementation of this extension in VS Code. I don't know how many things they have extensions for, you know. But I did want to show this because, but yes, I agree with you. I rebase all day, all the time in the old-fashioned way. But learning it was some of the most pain I've ever been in, because I worked at a place where I couldn't even tell them I was using the Git TFS bridge. Like, I had to ask all my questions in Twitter because they didn't even know I was using Git in 2012. But that was more than 11 years ago, and I came to improving, so. All right, yes. -F. It's a force push, and that's why it's very important that you understand the rebase workflow is only on your personal feature branches that no one has based their work on. And you can push it up to the remote, and that's fine as a backup. I rebase all the time, but you have to force push. It's just the same exact command with a -F. And I'm sure in the GUI there's a That's why. Because and I can add on to that, because Git's default when you do a Git pull is there's plumbing commands and there's porcelain commands. It's a Git pull is a Git fetch, which gets everything from the remote, and a Git merge. And so if anything has changed, it's just, if you're working in a branch that changed on the remote and you do a Git pull without a Git pull --rebase, then it will fetch, and then it'll create a merge commit if it differs, if it can't just fast forward your branch. And so then you have this merge commit that has all the commits in it. And to get around that, you can Git pull --rebase, and if you have work on top of it, it will automatically put your work on the top of whatever the latest on the remote is for that branch. That's why I'm trying to teach the word. I'm trying to. It just makes your history so much more readable. I work in a Guitar Hero repo right now, so. Well, I was gonna say you could show them this talk, but now you can't. Oh, that's why I branch all the time, because branches are free. Like we have a word for it here. It's get hobo. When I have a whole bunch of practice, like those test branches that I have like all locally. We're going to talk about squash in a minute too. Squash might be the best option depending on your coworkers, but I'm very opinionated on that too. No, the Rebase Interactive is what we just did, and it's only for your local branch. It's only for your personal branch. It's only for your personal branch. Yeah, and you can squash in there. Yeah. Yep. Well, we're gonna talk about squash in a minute. All right, so let's talk about cherry pick first, though. Okay, time check. Oh, we're good. So for this made-up scenario, let's say you've been working on features X, Y, and Z, and you need to get just the database scripts for each feature into a branch that gets promoted. Because you've created atomic commits with just your SQL scripts, you have made your life delightfully less complex. For each feature you work, instead of creating some huge commit that might randomly contain any or all of these files, followed by incremental changes that don't mean anything to the future person looking at your code, other than you didn't get it right the first time. So because the SQL work you did had been put on its own commit, let's create a new branch from main called features XYZ I'll then start with feature X branch. I can right-click on the commit I want to cherry pick and select this option from the contextual pop-up. This gives me this modal. Those are very cool options. By the way, this is the command line equivalent if you leave those boxes unchecked. And this is the command line equivalent if you check this box. Let's read get's man page on that option. When recording the commit, append a line that says cherry picked from commit X to the original commit message. Do not use this option if you are cherry picking from your private branch because the information is useless to the recipient. If, on the other hand, you are cherry picking between two publicly visible branches, for example, backporting a fix to a maintenance branch for an older release from a development branch, adding this information can be useful. So I should not click that here since it's my private branch, but I'm going to just show you what it does. First, let's look at our branches graph. Does that surprise anyone? Git compared the commit I cherry picked to its parent, calculated the diff, and applied that change to my branch. Does that make sense? Okay. The file was the only thing that changed in that commit. Yeah. And so it applied that delta to this, to my branch that I was on. So now let's look at the commit message. That could be helpful, and it's really good to know it's an option. Now let's cherry pick feature y.sql. Interestingly, the command line equivalent of choosing that checkbox is very similar. It says, hey Git, calculate the patch between you and your parent. Then apply the patch to the commit I'm on, but leave it in my staging. Do not commit it for me. So when I hit enter on yes cherry pick, check out my stage files view. This is a good way to pull files you want from a different branch into a branch. Like I do that a lot when I make test branches, when I'm doing my Git hobo test work, and I'm trying to figure something out I'm not sure I want to keep, but then I branch and try again and realize there's a file in one of my playground branches that I want to use. So we commit this, then cherry pick feature z.sql, and it looks like this. But now we want to merge our features xyzdb branch into our main branch. With main checked out, which you can tell by the hollow circle, we can right-click on our features xyzdb branch and choose merge into current branch. By default, VSCode checks create a new commit even if fast forward is possible when you do a merge, which is the equivalent of using the no FF flag below. Easy for you to say. So what does fast forward mean? Here we have main checked out. There have been no divergent commits. The only difference between main and what we're merging into main are the 3 commits on features XYZDB branch we're merging into main. In this case, Git prefers to do what's called a fast forward commit and just move or fast forward the branch named main to point to the commit here instead of creating an empty merge commit. By telling Git no fast forward, we're saying I want to merge commit even if fast forward is possible. So here, when we click enter or yes merge, with that checked, we do get a merge commit that tells us what branch we merged in. I want to show you again how certain GUIs can be misleading. That merge commit is actually considered an empty commit, but it shows all 3 files in the Git graph extension, which can be helpful too. And I'm not knocking it in any way, but I just want to make sure that we understand that that is a graphical representation that, although it's helpful, can be misleading. Since I could have fast forwarded that new merge commit, the new merge commit is only there to document that we merged that branch into main. No changes actually technically happened in the merge commit itself. But without the merge commit, we would not have a commit that told us that metadata that a branch had been merged in. So empty merge commits are good for documentation, like we said, like pull requests, for example. And let's look at this merge commit in GitK. See, it's comments only. There are no changes in the patch view. So let's wrap up Rebase with one final note. Let's switch to our feature X branch and Rebase onto latest main since it's been updated. We could type get rebase main or right click on the main branch and select rebase current branch on branch, which gives you this. We just want to get it up to date here, so hit enter, but I want to point something out. By default, it doesn't waste your time with what it calls empty commits. The way Rebase works is Git rewinds the history of the branch you're rebasing onto the common ancestor you both share. Then it fast forwards to your new base. Then, one by one, it cherry picks each commit onto that commit. Here, it will first try to apply the patch for this commit. But what's the curious thing about this one? Here's a hint. That diffs patch has already been applied in the history of what we're rebasing onto. So by default, it's going to be rightfully skipped. If there are no merge conflicts, Git moves on to the next one and cherry picks it onto the new cleaner branch history this is making. Here, it will cherry pick the added x1.txt commit, then the added x2, then x3, then x4. Then your history will be nice and neat and look like this. Does that make sense? Does anyone have any questions? Okay. And the last thing I want to talk about is squashing commits as another way to clean up your history. I have a really bad example, but hopefully an idea. Let's just say I want files x2 and x3 to be in a commit together because they belong together, because I believe in atomic commits. For example, if I make a change to the database scaffolding file and then I scaffold Entity Framework, I want that all to be together. I don't want those to be separate commits because they belong together. You know, like just something like that. So we've decided that X1 can be alone and so can X4, but for whatever reason, the files X2 and X3, they belong in a commit together. So if you think about what's technically happening, I really just want the root tree this commit is pointing to have a new parent. I click on one commit before what I want to change, select rebase current branch on this commit. I check launch interactive rebase in my new terminal when I get the message, are you sure you want to rebase feature X, the current branch, on commit F1434, whatever. then click Yes, Rebase. Then I can select Squash here. Once again, I'd like to point out this UI gives you an option of oldest first and an interactive rebase. It starts at the base and attempts to do what you ask it one by one linearly. I'll say it again. And this is only because it took me so long to go, all of my commits are in this order. Why in interactive rebase do they go from top down? And when like, I've been like doing this for like 10 years, and finally someone goes, oh, it starts from the top to the bottom. And I was like, oh, so easy. Like, it just made so much more sense. The reason I keep pointing this out is because if you do end up in the text version, it goes from the top to the bottom. The base isn't even listed, but you can think of it always at the top like this. In the text version, I'll say it again, Git applies each to the base one by one in order from top to bottom. The Git lens GUI gives you the option of oldest, newest first here. Base is displayed on the bottom. So it starts at the base and works its way up here where it actually has nothing to do because we chose pick this commit. Then it tries to apply what you tell it to here, which is squash. That's where Git basically kicks out the prior commit and points to the new parent. Finally, it applies this to the new squash commit that shows the new patch that includes both X3 and X4. So after I click Start Rebase, it gives me the option of making a better commit message. You can see here, this change includes both of these files together now, so I can change my commit message like this. After I save this and close, my history looks like this. You can see, yes, I changed my history, but I rewrote my own history to make it more readable, not just for my pull request, but for reading the repo history in the future. That being said, this is why I'm not a fan of squashing pull requests on merge. I work really hard to create atomic commits. There are times I'll refactor a code base, moving folders around. I do that on its own commit and note something like file move only, no other changes. Doing this as an atomic commit is important so people viewing the history later can ignore it instead of trying to figure out why this many files changed, for example. All of these here have 0 lines changed, which is great, but what if someone merges and makes changes in the same commit? Sometimes files do have to change to update references, but those also should just be in that one commit, no other changes. Make it easier for your future self and team to understand why changes occurred in your code history. If we all as developers do this, then pull requests that squash merge might have no place in our workflow. And I want to circle back to that because that's a very strong opinion that there is a time that it might be warranted, and that's, but let me talk about that in a minute. Don't let me forget. Squash merging a pull request would result in the same thing as checking this squash commits box and result in this one commit that includes all of these changes that we worked so hard to organize. So let's look at our new merge commit. Not only does it include all of our new feature X files in a single commit when we worked hard to keep the ones that belonged separate in their own commits, but it also includes all of the renamed and moved files. So the reason that I have pause in that sentence is I am very opinionated about it. It's because I work so hard to organize my commits and make them readable and atomic. And if you need to undo something, you have that whole, you can revert a commit in its atomic state. But someone brought to my attention when I did my talk at that conference that when you merge into prod, if you do a squash merge to the map to whatever the production branch is called, right? Like whatever you're calling that production branch. We actually have changed it to call it production. So we have production and then we have next release because people were abusing the dev branch. But if GitHub or whatever you're using allows you to just squash the PRs that go to production, then I could see that as an absolutely valid use case because that can enable you to revert that entire release if you have to, in a single really easy commit it makes it very easy to tell what's happened. And then you would just merge that merge commit back down and in theory have no changes, but you would have that whole history. And then you would just have an extra commit that does include everything, but you still keep all of the work in your main branch or develop or next release or whatever you call your main develop branch, right? What? Today they are, but what about tomorrow? Right. That's why you have control. You can squash them and reorganize them however you want to before that PR is made. Like you have tools that will enable you to clean up your history before other people have to see that garbage. Trust me, I have garbage everywhere, but do those make it into the pull request? No. Do my whip commits make it into the pull request? No. Yes. Yes. And I love it. And it helps future you when you're trying to see how the heck the code got this way, right? Like, why does what, you know, and like with these Guitar Hero merges, like, I got nothing. But this guy had this enough function, made this drama, these now suddenly, I wish they just give me the option. Let me do either one so that I can see. Yeah. But, for some bizarre, reasons, it's like, whatever. Now I'm forced into this flow, and I have all of these risks, and I just merge maps in here, and now I can't do anything about the risks, and I don't. All these little things. So do I, which is why I'm here today. Yeah, yeah. And everything changes from team to team, from project to project. Everything changes, and you have to pick and choose your battles. And there are some hills I've chosen to die on, and some hills that I'm like, oh, maybe this guy will leave soon. So. All right, so hopefully I planted a little seed that could help start the shift. It sounds like already you're starting to think a little bit differently about just how Git works under the covers. Like, it's just really beautiful. It's so, like, simple in the beautiful way, not simple in the, that's trivial. Oh, I hate it when people say that. But just simple in the beautiful way. It's made up of 4 objects and just a lot of amazing math. Hopefully you can start interacting with Git from fear and loathing and dread to, starting to be more interested and just better understanding. The Truncated Coder is my blog, and it's named that because if you truncate my name, Corey Drew, you get coder, and I'm a coder. So I blogged way too much when I was trying to find my place in the tech community. I captured and overshared my learning experience, as you could see when I quoted how repulsed I was by having to learn command line for version control. But the important part is right here, is where you can find the link to the best Git videos I have ever seen. Like, if everyone would watch his videos, I would never have to speak again. He's amazing. Like, these videos are the best. So that link has a playlist of 13 videos whose titles include like Git internals intro, that one's really good. Git objects, branches, creating a repo from scratch, rewriting history, overcoming, I'm not going to say that word because it's too hard. Git disasters, Diffs and Patch. There's a live talk from him that he did in New York City. Git merge and rebase. Rewrite history with confidence. advanced merges, get diff merge versus rebase summary. So that is the URL. I really highly recommend that. And like I said, the link to the entire playlist is right there. And here is that QR code. If you'd like to learn more about improving and register to win $50. Thank you, everyone.